Assalamu alaikum wa rahmatullahi wa barakatuh. Okay, so this mega compilation is basically what I've been talking about. The point of this is to give you a real fighting chance for the physics exam. I hope you enjoy it and I hope you end up using it successfully to get the highest grades on your physics finals. The way I intended for you to use this is by doing the questions before I do them. So basically, pause the video, answer the question, and then check your answer with me after I do it. Um, so, just a few words before you go through the whole video and you do the questions and you do the answers and check your answers and so on. I wanted to say for the upcoming exam, please make sure that you're aware that these are the topics that are being covered in the exam. Be familiar with the vocabulary. Okay, go through your book, read through your book at least once. Read through your booklets. If you have booklets to read through those. Make sure you're familiar with the terminology. Um, I've got something here written here, brain, body, boss. And what you're supposed to do is basically use your brain. If you don't understand something, use your brain. So what does that mean? It means read through it again, read through it again, read through your notes. Find a YouTube video that is useful. There are literally tons of YouTube videos out there on every single topic in physics. Khan Academy is a very, very good academy that I use personally. So Khan Academy is very good. Another way is if you still don't understand it, contact a body. Okay, so contact a friend of yours, contact a classmate, contact a brother, a sister, a cousin, whatever you can. So just try and use somebody, a friend, to explain it to you. Okay, and be that friend as well. If you understand it, be available to your friends, be available to your classmates, explain to them. The highest form of understanding is to explain it to someone else. Okay, so there is I understand it, there's I can do it, and then there's I can synthesize it, which means I can actually explain it to someone else and come up with questions too. Okay, and that's how you know you really understand it. And if you're still struggling, then you have a boss, and the boss is either your teacher or your perhaps your older brother, if you have an older brother who's gone through this, or if you have a father or a mother who's physics oriented, perhaps an engineer or some sort of teacher, then you can ask them as well. Be ready for the exam, be prepared, have extra pens, have extra calculator. I always have an extra calculator. I always have an extra calculator. So that's me, okay? And so please make sure that you always have an extra calculator with you coming into the exam. Watch the videos, do the questions, and remember your key skills, things like triangle formulas or formula triangles, data handling, and that sort of thing. You will be fine. All the very best. Good luck.
Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome back. This is the start of a series we're doing before the exams, and we are going to be, inshallah, doing some questions for each one of the units that we're covering for the exams. Okay, so what I'd like you to do is please bring your calculator and your paper, and please try and do these questions with me as I go along. Okay, so just a word before we start. First of all, just a quick word. So these videos are supplementary to your own study. So what that means is they don't replace the book, they don't replace your own notes, they don't replace any material that the teacher has given you. In my case, the booklets. Okay? Your book and your notes are the main source of study. If you need extra help understanding the chapters, please watch the original unit video lesson. So what that means is if you want to watch, for example, if you want some in-depth explanation of Unit 5.1, just watch the video on Unit 5.1, which I will be putting in the link in the description below the video. Thank you. Okay, so let's go. So this should be quite short. The point of these videos is just quick practice. I don't want to make them too boring, so they should be about 15 to 20 minutes long, maybe even less. Let's go. So this is from the revision pack. I'm going to attempt to answer this one first before I give you some more questions. If the force acting on an object doubles, what happens to the object's acceleration? If the mass of an object doubles, what happens to the object's acceleration? So the easiest way to do these questions is by simply picking some numbers at random and putting them in. Okay, so pick some numbers, put them into the formula and see what happens. So the formula says force equals mass multiplied by acceleration. So this is, remember this is question one. So if I go with some numbers here, So if the mass is 1 kilogram and the acceleration is 2, then the force is going to be 2 newtons, right? So the first question says, what happens if the force acting on an object doubles? What happens to the acceleration? So of course the mass of the object stays the same, but we are now doubling the force. So what's going to happen to the acceleration? Well, 1 times 2 does not equal 4. It equals 2. But now, if we double the force, we are going to double the acceleration, aren't we? That's the only way that makes sense. So, what happens if we double the force? We double the acceleration. What happens if we halve the force? We halve the acceleration. That's how we answer that one there. So that's part A. What about part B, where it says, if the mass of an object doubles, what happens to the object's acceleration? Okay, well, let's have a look. So, assuming the force stays the same this time, so the force stays the same, let's keep it at 4 newtons, and the mass goes from 1 to 2 kilograms, what happens to the acceleration? Of course, it's going to halve. So that is the answer for question 1. Part B. If the mass is doubled, the object's acceleration is halved. And that makes sense, just generally speaking, thinking about it. If an object is double the mass, then it's going to be harder to accelerate it, isn't it? Okay, and the acceleration is going to be half of the acceleration of a lighter object. Okay, so that's as far as question 1 is concerned. If we double the mass, we have the acceleration. If we double the force, then we double the acceleration. The other way to think about it is if you think of a ball, for example, if you kick the ball, then you got to give it some acceleration. If you kick it twice as hard, then you're doubling the force, twice as hard. That's what we mean by doubling the force. You're kicking it twice as hard, then it's going to accelerate twice as much. Okay? That's what that means. Question 2, Question 2, what net force must act on a 540 kilogram golf cart to give it an acceleration of 2.5 meters per second? Once again, force equals mass times acceleration. This is going to be your best friend, this formula. Doing anything to do with Unit 5, Newton's laws of motion, this is your best friend right here. So we have the mass, and we have the acceleration. What's going to be the force? The force is going to be mass times acceleration, which is approximately 1,200. 540 multiplied by 2.5, so 1,350. Okay, and what's the unit? Newtons. Okay, so here's the way you answer an exam question. Okay, just for those of you that are not sure. The way to answer an exam question is look for those 4. We always look for 4 things when we're marking. We always look for 4 things. What are they? Formula, workout, answer, units. Okay, let me repeat that. Formula, workout, answer, units. So please make sure that you, first of all, you write the formula, because that way, even if you get it wrong, we can give you some of the mark. You do the workout. Of course, we want to see the workout. We want to see the answer, and we want to see the correct units. That's how you make sure you get the full marks. Okay, so that was question 2. Let's go to question 3 now. Question 3 says, a 1,800 kilogram truck pulls a 620 kilogram trailer from the stoplight, so that means from 0, and accelerates at this much. What is the force exerted by the truck on the trailer? Now, this is a bit of a trick question because it doesn't really matter what the mass of the truck is. It's like saying if I'm pulling a car, or if I'm pulling an object, or if I'm pushing a box, does it matter what my mass is? No. What matters is the box, right? So here, so that really doesn't matter. I have a trailer, and the mass of the trailer is 620 kilograms, and the acceleration of the trailer is 1.16 meters per second squared. And once again, we need our best friend here. And so it's going to be, that's the formula. Okay, this is the known and the unknown. So what's the unknown? I don't know what the force is. Here's the workout. Mass times acceleration, 620. F equals 620 times 1.16. And that will give me the acceleration, the force, which will be 719.2. Now we are working with two significant figures, so 720 newtons. Okay, and that's how you do that one. Hopefully not too hard. Excuse me while I take all of this off. Okay. And of course, just want to say something here. If you prefer working with triangles, I like working with triangles. So you can always write the triangle form, and that way you can cover what you want. Because obviously in the exam, you will always be given two and be asked for the third. Okay, so you might be given acceleration and force and be asked to work out the mass, or you might be given mass and acceleration as the example now, or you might be given force and acceleration or force and mass and be asked to work out the acceleration. So always a good idea to work with the triangle if that's what you prefer. Okay, question 4 says a 91 kilogram parent, this example has come to us so many times, and the 21-year-old and the 21 kilogram child, okay, are sitting in the middle of or the center of an ice rink. They place their hands together and push, so they push each other apart. Okay? Is the force experienced by the child more than, less than, or the same as the force experienced by the parents? Well, I can tell you right now, Newton's third law says for every action there's an equal and opposite reaction. The forces are equal. The forces are equal. The acceleration is not equal, the mass isn't equal, but the forces are. Okay, so force equals mass times acceleration. Now, the mass of the father is different to the mass of the child. If the masses were the same, then the forces would be equal in magnitude as well. But the masses are not the same, therefore the acceleration is not the same, even though the force is the same. Okay? And we're going to come to understand what this means. Now, is the force experienced by the father or the child, are they the same? Yes, they are the same. Now, next thing is asking, B, is the acceleration of the child more than, less than, or the same as the acceleration of the parent? Of course, the acceleration of the child is going to be more than the acceleration of the parent. Why is that? Look at the formula. Look at the formula. If the force is the same, but the mass of the child is less, then the acceleration is going to be more. Okay, let's take an example. If the force acting is 200 newtons, the mass of the child is 20 kilograms, then the acceleration of the child is going to be 10. If the force acting on the father is 200 newtons as well, but the mass of the father is 100 kilograms, then the acceleration of the father is 2. So that's common sense, isn't it? If the mass is more, the acceleration is less. Anyway, let's keep going. They've given us some numbers here. If the acceleration of the child is 0.31, so now we know that the acceleration of the child equals 0.31 meters per second squared. What is the magnitude of the father's acceleration? Okay, so just remember that they are accelerating in opposite directions to each other. So I know that force equals mass times acceleration. Remember, always start by writing the formula. And I know that the child's mass is 21, while the acceleration of the child is 0.31. That means that the force acting on the child is going to be 21 times 0.31, which is equal to 6.51 newtons. Okay? And since we are working with two significant figures, it's going to be 6.5 newtons. Now that's going to be the same as the father. Okay? So the father's force is also going to be 6.5 newtons, except I'm going to write it as negative 6.5 newtons because they're in the opposite directions. It doesn't matter which one is negative, which one's positive, as long as they are opposite each other. If one is negative, the other is positive. If one is positive, the other is negative. Okay, it doesn't matter. Do we have the mass of the father? Yes, we do. The mass of the father is 91 kilograms. You can certainly work out the acceleration, can't you? So force equals mass times acceleration, obviously. So that's force, that's mass, times acceleration. We're trying to work out the acceleration. So it's going to be negative 6.5 divided by 91. So it's going to be negative 0.07. Oh, yep. meters per second squared. Now here's the thing. I don't actually have to have the negative there because it's asking for the magnitude. You see that? So it's not even asking for the acceleration, it's asking for the magnitude of the acceleration. They're being nice. They just want the number. So that is technically correct, but really it's 0.07 is fine. Okay, let's move on. I told you I want to keep these videos short, so we're going to keep them under 20 minutes. When a bus starts suddenly, the passengers are pushed back. This is an example of what? The passengers are sitting down, okay, they're not moving, they don't want to move, their bodies don't want to move. The bus forces them to move. This is Newton's first law, the law of laziness, the law of inertia, the law of stubbornness. Objects that don't move don't want to move. Objects that are moving don't want to stop. Okay, and so the passengers are not moving. They don't want to move. The bus forces them to move. What's going to happen? They're going to move back because they want to stay in their position. Okay, so this is first law, also known as the law of inertia. My apologies. I am planning on getting a new Surface Pro, which will make the writing experience so much better. So I'm just waiting for a while. Right, let's move on. A feather of mass 15 grams is dropped from a height. It is found to fall with a constant velocity. What is the net force acting on it? Interesting. Here's a feather. It is falling. Okay, and here's the ground. Okay, so it's falling to the ground, and we're being asked to calculate the net force acting on it. So here's the thing. It's a trick question. Why? If it was just falling, simply falling, then we know the acceleration towards gravity. Well, force equals mass times acceleration, and the acceleration towards gravity is 9.81. But it's telling us it's falling at constant velocity, which means there is no acceleration, or acceleration of zero. If the acceleration is zero, it doesn't matter what the mass is, what's going to be the force. The force is going to be zero, okay? So that's simply it. So it's going to be force equals mass times acceleration. And since it doesn't matter what the mass is 0.015, but since the acceleration is zero, then the force is equal to zero. Okay, that's why. Constant velocity, no force acting on it because there is no acceleration. Next, here's a question that requires a little bit of work, but it's basically as hard as they come when it comes to 5.1 or talking about force equals mass times acceleration. Let's have a look. A 1-ton car accelerates from a complete stop. That should say from a complete stop. Okay, from a complete stop to 60 kilometers per hour in 10 seconds. What force is applied by the engine to move the car? Don't panic. The first thing to do is to look at what you have. You have the mass, 1.2 tons. Do you have the acceleration? Well, you can work it out. The acceleration is change in velocity over time, which means 60 kilometers minus 0 over time. And we can work out the force by the engine. Just a couple of steps before we do that, because we need to change 1.2 tons to kilograms. So a ton is 1,000 kilograms. 1.2 tons times 1,000 equals 1,200 kilograms. So that's sorted. Alhamdulillah. That's one thing out of the way. Let's look at the acceleration. How do we do the acceleration? Well, we've got the acceleration in kilometers per hour. So what do we need to do? Change it from kilometers per hour to meters per second. So 60 kilometers per hour, which is 60 times 1,000, because it's 60,000 meters, divided by 3,600, which is, okay, do you want me to do the conversion? I'll do the conversion. 60 kilometers is equal to 60,000 meters divided by per hour. So in an hour, how many seconds in an hour? We've got 60 minutes. Each minute has 60 seconds. So it's 60 times 60, which is 3,600, which is equal to 60,000 divided by 3,600. So it's equal to 16.7 meters per second. That's the final velocity. Minus 0 divided by 10, that's going to give us the acceleration. So we've just worked out 60 kilometers per hour is equal to 16.7. So instead of writing 60 minus 0, I'm going to write 16.7 minus 0 divided by the time. What's the time? 10 seconds. So that's going to give me the acceleration. Okay, sorry, if I was moving a bit too fast, please pause the video, go back, look through it. It's just that I want to keep the video short. So minus 0 divided by 10, and that's going to give me an acceleration of 1.7 meters per second squared. Now that I have the mass and the acceleration, I can work out the force. (1,200) times 1.67. Now, here's the thing though. When I'm doing my workout, I don't actually use 1.7. I don't round till the very end, and that's to avoid errors, okay? So I'm actually using 1.67, 1.66666, okay? And when I'm doing my workout, when I'm doing my calculations, it's essential that you do the same thing. That way you don't actually carry forward any error, because in the end, once you do it properly, you actually get a nice round number, 2,000 newtons. That's how much force the engine needs to apply. Okay, I hope you enjoyed that. I'll see you in the next one. Adios.
Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome back. I hope everybody's been doing well, and I just want to say I've got some exciting news. I've got a new microphone, so hopefully you can hear me slightly more clearly. We'll see. Anyway, so let's get on with it. I'm trying to keep these videos nice and short. Let's have a go. So we are talking about Newton's laws. So what I'm going to do is I'm going to attempt to answer these from the revision pack, and then I've got one more question to do, and that's that. So let's start. The first question says a brick is at rest on a tabletop. A spring is then attached to the top of the brick and stretched by someone pulling up on it. The brick remains at rest. Is the normal force acting on the brick greater than, less than, or equal to the brick's weight? And explain. Here's the tabletop. Here's a brick. So the first thing we need to realize is that the brick has a weight force, and there is a reaction force, what we call a normal force, acting on it. And these two are equal and opposite. They are equal and opposite. So let's say, for example, the brick is 5 newtons. Then this would also equal 5 newtons. Now, what the situation here is that we have a normal force, and now somebody decided to attach a spring and is pulling on it. The brick is still not moving, but now we have two forces. We have tension force from the spring as well as normal force, and they are both equal to 5 newtons. So instead of before it was normal force equals 5 newtons, now it's tension force plus normal force equals 5 newtons. So plus normal force is equal to 5 newtons. So that means what happens to normal force? It got less. Normal force reduced. So it's less than before, because now we have another force supporting it. Okay? Next, we have a parachutist who jumps out. So we've got an example here of a parachutist, a jumper who jumps out of a plane, and after an extended period of free fall, just a second, somebody's calling me. And we're back, sorry. So as I said, a parachutist jumps out of a plane and they're in free fall for a while. So why did they say that? Why did they say they're in an extended period of free fall? That's to say that they have reached terminal velocity. They're not accelerating anymore. They're not changing velocity. So to decelerate your fall,
must the force exerted by you in the parachute be greater than, less than, or equal to your weight? Okay, so that's a tricky one. So you're falling down and you're trying to determine, and of course there is the acceleration towards gravity pointing downwards, and you're trying to slow down. So what do you need to do in order to slow down? You need to counter that acceleration towards gravity in the opposite direction. So if you are falling downwards and there's g, you need to counter g with a negative acceleration. If we consider this positive, then you need to counter it with a negative acceleration, and that will slow you down. Okay? And another way to put it is, see, when you jump out of a plane and you open your parachute, okay, the force exerted on you by the parachute, that means the force that the parachute is holding, has to be greater than your weight. So it creates air resistance, which pushes against gravity, which slows your fall down. Okay. Let's try and work it out mathematically. Okay, so let's say the force from gravity is equal to mass times acceleration, and let's say you have a mass of about 70 kilos, and the acceleration of towards gravity, the acceleration will be 9.81. Okay, so now basically you have an overall force of approximately 690, 70 times 9.81, 70 times 9.81, which is approximately 687 newtons, right? Now, if I'm to counter this, let's say, for example, I open the parachute and the parachute creates a force upwards of about 1,000 newtons. This is what we call drag. Then we have a force downwards of 687 newtons and a force upwards of 1,000. That means the overall force acting on the parachutist, the person falling down, is going to be 313 newtons. And we know force equals mass times acceleration. If we have 313 newtons acting down and the mass is 70, then suddenly the acceleration is a lot less, which is 4.5 meters per second squared, as opposed to 9.81. Okay, so obviously this has reduced. So that's what you need to do. You need to have a weight force that is greater than your weight force. The force exerted on you must be greater than. So which one of them would be the correct one? A parachute can only exert a force that is less than the weight of the skydiver. That's not true. A parachute exerts a force exactly equal? No, because if it was exactly equal, they would continue to fall at the same rate. To decelerate, they must exert a force that is opposite. In fact, this is what's happening here. So this is negative 4.5 meters per second squared. Why is that? To counter gravity. Gravity is 9.81 meters down, and this is negative 4.5 meters up. So what is this going to do? It's going to slow the person down. So if they are moving initially at say, for example, 50 meters per second, or yeah, that's approximately correct. Let's say they're moving at a rate of 50 meters per second at minus 4.5 meters per second, and let's say, for example, after 10 seconds, then their speed would be negative 4.5 times 10 seconds is equal to negative 45. The initial speed is 50 plus negative 45. Their speed, the final speed, would be 5 meters per second. So it would slow them down. Anyway, the option is C. Sorry if it's long and winding. Let's look at the third example here. What are we doing for time? 7.5 minutes. Inshallah, we'll finish before 20 minutes. 3 astronauts. 3 astronauts use their jetpacks to push on a satellite in deep space. Astronaut 1 exerts a force of 52 newtons in the positive x direction. I'm going to draw the satellite. Here's the satellite. And there's 52 newtons in the positive x direction. Astronaut 2 exerts a force of 35 newtons in the negative y direction. Astronaut 3 exerts a force of 74 newtons at an angle of 63 above the x-axis. Okay. Use a ruler and protractor to determine the approximate direction of the magnitude of the net force acting on the satellite. Well, I'm not going to use a ruler and protractor. If the satellite has a mass of 680, what is the magnitude of the acceleration? Okay. So instead of using a ruler and protractor, I'm just going to do it mathematically. And how do you do it mathematically? Well, the key is this guy here. The key is trying to work out the x and y components of this, which of course we use SOHCAHTOA for that. So we are trying to work out this component and this component here. Okay? So in order to work out this component, the opposite side, then we use sine 63 multiplied by 74. And that gives us 66 newtons in this direction. And then we have cos 63 multiplied by 74, which gives us 33.6 newtons in this direction. Now what do we do with that information is we add these. Now this is the y and this is the x, and this is the y and this is the x. Now we're just going to be careful with positives and negatives. So you can see that both x's are facing the same direction, so it's going to be 52 plus 33.6. So overall, that is what a new triangle looks like. We have 85.6, and then we have 66 that is positive, and 35 that is negative. Okay, so it's going to be 66 minus 35, which equals 31. Overall 31, that's positive. And now we can work out the new angle. How do we work it out? We use tan. 31 divided by 85.6, which is opposite over adjacent. Then shift tan. And that gives us the new angle, which is approximately 20 degrees. So we know the direction. We know the direction is at 20 degrees, but that's not what they're asking for. They're asking for the acceleration. How do we work out the acceleration? The rules haven't changed. Force equals mass times acceleration. So first we have to work out the force, the overall net force, using the x and y components. And then once we work out the force, we divide it by the mass and we get the acceleration. So we have 31 and 85.6. What do we do to get this? A squared plus b squared equals c squared. We're trying to work out c squared. So it's going to be 31 squared plus 85.6 squared. Square root of both of these equals 91. So this equals, the hypotenuse equals 91 newtons. Okay, now I have the force, which is 91. I have the mass. They told me the mass, right, of this satellite, 680 kilograms. I have the mass, I have the force. So it's going to be 91 divided by 680, which equals A, acceleration is equal to 0.13 meters per second squared. Now notice I didn't actually go through the boring steps and everything else. And that's kind of deliberate in a way. I want to give you the answer, but I also want to give you a chance to struggle a little bit with it. So what I want you to do is I want you to go through it. Okay, and if you do understand it, that's fantastic. Try and explain it to a colleague. Try and explain it to a classmate. The best way to know that you understand something is by explaining it to someone else, is to play teacher and explain it to someone else. Okay, how are we doing for time? We're at 13 minutes. Let's go to the last question. To give a 19 kilogram child a ride, two teenagers pull on a 3.7 kilogram sled with ropes as indicated in figure 5.24. So this is figure 5.24. Both teenagers pull with a force of 55 newtons at an angle of 35 relative to the forward direction, which is direction of the motion. In addition, the snow exerts a retarding force. That means it causes friction on the sled that points opposite to the direction of the motion and has a magnitude of 57. Find the acceleration of the sled. Diagrams make everything so much easier. Find the acceleration of the sled. Okay. Now obviously the sled is moving forward, but they are pulling at an angle. So what we need to do is work out the force A, which is moving forward. That's what we need to work out. We're not interested in the hypotenuse, in the force at an angle. We're interested in the force in the same direction as the movement. Okay? So what do we have? We have the mass of the child as well as the sled. We need both because they are together, the mass of the child and the sled. Hopefully you recognize that. That's the first trick in this question, is that you need to realize that it's the sled and the child together. That's the first thing you need to recognize. Second thing is, we need to work out this force A. How do we work out force A? Well, the rules of mathematics have not changed. This is the adjacent. If we look at the triangle here, we have the hypotenuse. We need to work out the adjacent. And remember, there's two of them. They're exactly the same. So here's what we have. We have 55. We have an angle of 35. We need to work out this side A. And if we work one, we can do both. We can just double it because they're both exactly the same. So how do we work out the adjacent? Cos 35 multiplied by 55. This gives me A is equivalent to 45 newtons. There's two A's. Why? This guy is pulling and this guy is pulling. They're both pulling. So they're going to produce 45 times 2, which equals to 90 newtons. Are we done? No, of course not. We have a pullback of 57 newtons. That means the snow is slowing it down by a factor or magnitude of 57. So it's going to be 90 minus 57 to work out the overall net force. It's going to be 90 minus 57, which equals 33 newtons. So the overall force acting on the child with the sled is 33 newtons this way. Are we done? No. No, we're not done. Again, we have to go back to force equals mass times acceleration. We have 33 newtons equal to 22.7 multiplied by the acceleration. So the last bit is now basically dividing by 22.7, which gives me the acceleration. Therefore, the acceleration is equal to 1.46 meters per second squared. Okay, as I said, the best way to do this is by doing it and then trying to explain it to someone else. All right, we have kept it at 17 minutes today. Okay, thank you. Over and out. I will see you in the next one, inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome to another one of those sessions. We are at unit 5.3, which means we are really close to finishing because we only have unit 7 to do after this, inshallah. And then we'll be done. Anyway, we're trying to keep these short, so we're just going to get on with it immediately. Hope you have your calculator and your paper and your pen ready. Let's go. Okay, so here we have a question with a chimpanzee. A 22 kilogram chimpanzee hangs from the end of a horizontal broken branch as shown in the figure below. The branch sags, which means it goes down a bit, downwards through a vertical distance of 13 centimeters. Treating the branch as a spring satisfying Hooke's law, what is its spring constant? Okay, So the first thing we need to know is that we have to be aware of what terminology means. What do these terms mean? What does Hooke's law mean? Well, Hooke's law is this. Force acting on a spring is equal to the spring constant multiplied by the stretch or the extension. Okay, so this here means extension or stretch, and that is measured in meters. Oh God, it's so hard to write on glass. That's measured in meters. Then we've got spring constant, and that is Newton per meter. Okay, so we've got those two things. Once you understand those, oh, what's happening? No. Once you understand those, inshallah, it'll make everything a little bit easier. Okay, so we're back. So the first thing we need to do is work out the force. We can work out the force because remember, force is also equal to mass times acceleration. So force equals mass times acceleration. In this case, it's also equal to mass times gravity. We have the mass, which is 22. We have gravity, which is 9.81. So we can work out the force acting, or the weight in this case, which is approximately 215. 9.81, 216 newtons. So now that we've got the force and we've got the extension, but what do we need to do with the extension? We can write it as 13. We can just say 216 equals k multiplied by 13. That 13 has to be changed because it has to be in meters, right? So it's going to be 13 divided by 100. We have to change that to meters. So we have 13 divided by 100, which is 0.13 meters. So that's what we have here, 0.13 meters. Okay? So how to work out K? K is going to therefore equal 216 divided by 0.13, which is a big number. It's a big number. It's not usual to be this big. 1662 newtons. We are working with two significant figures, so that's going to be 1700 newtons per meter. Okay, that's the answer. 1700 newtons per meter. Let's move on. We are doing well. In a daring rescue by a helicopter, 2 men with a combined mass of 172 kilograms are lifted to safety. So we have 2 men, okay, that are kind of hugging each other, I guess. Okay, and they are being rescued by a helicopter. Okay, they have a mass of 172 kilograms. And what is the question asking? If the helicopter lifts the men straight up with a constant acceleration, is the tension on the rescue cable greater than, less than, or equal to the combined weight of the men? Okay, so it's lifting them up straight up with a constant acceleration. Okay, if it was just simply holding them in place, then it would be equal. What do I mean by that? Like if you have a string and you have like a ball at the end of it, then there's a weight force downwards and there's a tension force upwards through the cable. They are equal then. But if I'm lifting it up, and this is what this is saying, I'm lifting it up. I'm not just keeping it still, I'm lifting it up. If I'm lifting it up, then suddenly this here, the tension, is bigger than the weight. It's bigger. Has to be bigger. Okay? So is it greater than, less than, or equal to? It's greater than. Has to be. Okay? Why? Because it's accelerating upwards. Okay, if it wasn't accelerating upwards, if it was exactly the same, like just hovering, then it will be exactly the same. If it was falling down, then the downward force, the weight, would be greater than the tension force. But it's not, it's accelerating upwards, it's going up. So if it's going up, then that means the tension has a greater force. Now, how much of a greater force? The next question says, determine the tension in the cable if the men are lifted with a constant acceleration of 1.1 times 10, 1.1 meters per second squared. So in order to work that out, we need to know that the tension force is equal to the weight force plus 1.1 meters per second squared acceleration up, whatever that force is going to be. So let's start working. The weight is equal to mg. So that's going to be 172 multiplied by 9.81. The tension is going to be equal to that, 172 times 9.81, that's a given, plus it's also going to be 172 multiplied by 1.1. Why 1.1? Because remember, force equals mass times acceleration. So we have a balanced force, which is equal to the weight initially, but also now we have acceleration. So that new force is equal to the mass multiplied by the acceleration. And so we have two forces acting. So the total tension in the rope is going to be equal to the weight plus the acceleration. So it's going to be a total of that plus 172 times 9.81 plus 172 multiplied by 1.1, which is the acceleration, and that's going to be equal to 1,850 approximately. That's what I'm getting. 1,850 newtons. Okay. Right, the next one. These questions are a little bit tricky. Take your time with these, okay? Go back through the video, try and understand them. Pause, reflect, go back, think about it again. If you need to message me on Teams, please go ahead. Ask your friends though. Remember the 3 B's: brain, body, boss. Use your head first, okay? Try and understand it, struggle a little bit. That pain, that's going to cause you to actually learn, okay? If there's no pain, there's no gain. So you need to struggle a little bit, okay? Try and work it out yourself. Try and look it up on Google. Try and look it up on ChatGPT. Try and work it out yourself. Now, if you can't, use a body, brain, body, boss. Use a body of yours. Call your friend. Ask them to explain it to you if they understand it. If you both don't understand it, then you call your boss, i.e. the teacher. You call me, you send me a message, and you tell me, hey, can you please explain this to us? We don't really understand it. Okay. Let's go to question 3. 2 workers pull on a raft through a lock, as shown in the figure. One worker pulls with a force of 130 newtons at an angle of 34 degrees. The other one pulls with a force of 45, and it doesn't tell us what he's pulling with. Oh, that's what we're trying to find out. We're trying to find out what force, size F, is needed to make this raft go in a straight line without swerving. So in order for it to go in a straight line, the first thing you have to understand, the first idea, is that in the y-axis, this has to be equal to this. They have to cancel out. Once we know that this has to be equal to this, because remember, there has to be no net force in the y-axis for it to go in a straight line. And now it becomes easy, because then if you can work out the size of this, then you can work out the size of this. And then khalas. And then once you work out the size of this, they can work out the size of, well, now you understand it. Let's see. So it's a triangle. This is what we have. We have 34 degrees here, and we have a hypotenuse of 130 newtons. So we're trying to work out this force here, what we call the opposite force. I'm going to call it opposite force. So I'm going to use I'm going to use sine 34 multiplied by 130 and that's going to be 72. Is that correct? Let's have a look. Let me just check that one more time. Toa, I'm using sine because it's the opposite that I'm trying to find. So it is sine 34 multiplied by 130. That's going to give me 72. So this is going to be 72. That means that's going to be 72 as well. And now it's easy. Now I'm going to use this 72 to work out the size of f at an angle of 45. So once again, I'm going to use 72. This time I'm going to use it differently though. So it's going to be sine angle equals adjacent over hypotenuse, yeah? I've got the adjacent, I've got the angle, I don't have the hypotenuse. So if it's going to be sine 45 equals 272 divided by f. So obviously it's 72 divided by sine 45. And that's going to equal 102 newtons. So the answer is 102 newtons. What are we working with? We're working with 2, 3 significant figures. Doesn't matter. 100 newtons. If you want to be specific, it's 102 newtons. All right, let's go. Next, trying to keep it less than 15 minutes for a change. A book weighing 2 kilograms. Here's a book. And it has a mass of about 2 kilograms. And it's sitting on a table. Oh, I made the table 3D. I have to make the book 3D now. Okay, there we go. With this coefficient of static friction of 0.3, and what is the minimum force required to start sliding the book across the table? Force equals this guy multiplied by the normal force, which is normal force. That's just mg. That's the same as the weight force. Okay, remember weight acts downwards and then normal force acts upwards. So what's going to be the weight force? The weight force is going to be mg, which is equal to 2 times 9.81, 19.9. No, 19.6, right? 9.81 times 2. So 19.6, yeah. So that's 19.6 newtons. And therefore the normal force is equal to 19.6 newtons, right? So I've got 19.6 newtons multiplied by 0.3, which is equal to approximately 0.59. Sorry, 5.9, not 0.59. 5.9 newtons. That is the minimum force required to move the book. Okay, hopefully that wasn't too difficult. Please go back through this if you need to, and remember what I said today. Ask a friend, look online, and you can always ask me. Have a good one. See you in the next one. We kept it at less than 15 minutes. Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome back. This is going to be a session where we record the answers to the revision pack for the grade 11 exam unit 7.1 to 7.4. So what I'm going to do is I'm going to answer the questions in the revision pack. As always, please try and answer the questions before I answer them myself. Okay, so this is what I'm planning on doing, is I'm going to be answering these questions. It's going to be a slightly longer session because I'm going to be doing all four, 7.1, 7.2, 7.3, and 7.4. And then after that, I've got some questions and answers as well in multiple choice and conceptual and calculation form. So, and then what I'm planning on doing is compiling everything in one mega video revision. Okay, so let's go. I don't want to waste any more of your time. Right. We are going to be answering these first. So first and foremost, just give me a second, sorry, while I set myself up. Here we go.
we've got a question here that says mass and speed data for 4 objects are given below. Rank the objects in order of increasing magnitude of momentum. Indicate ties where appropriate. So in order to answer this question, we need to recognize that, obviously, here it is, question 1. We need to recognize that momentum equals mass times velocity. And once we understand that, and we know that that there is mass, and that there is velocity, or speed in this case, then we can answer the question. And so I know I'm just going to do this instead. I'm just going to add momentum over here. And so 1 times 1 equals, oh, why did my video suddenly stop? Just a second, let me try and fix this. Okay, and we're back. Magic. So as I said, what I'm going to do is I'm going to put momentum down here, and then so 1 times 1 equals 1. Oh, and we're off again. Why does it keep doing that? Is it going to work this time? We'll see. 1 times 1 equals 1. 2 times 3 equals 6. 0.1 times 2 times 20 equals 2, and 5 times 0.2 equals 1. Okay, so which one is the most? Indicate rank in order of increasing momentum, increasing magnitude. So be careful with that in the exam. Increasing means you start with the lowest. Okay, so obviously 1 times 1 equals 1, but also 5 times 0.2 equals 1. So both of these, so the rank would look like this: A, D, followed by C, followed by B. Okay, let's go to question 2. Question 2 says, soccer player 1 has a mass of 45 kilograms and moves to the right with a speed of 1.4. So here we go, here's soccer player 1. Okay, and he is moving to the right with a speed of 1.4 meters per second, and his mass is 45 kg. And we've got, what else do we have? Soccer player 2 has a mass of 32 and moves to the left. So soccer player 2 has a mass of 32 kg and moves to the left with a speed of 2.1 meters per second. I am using a new tablet to write with, and it just takes a little bit of getting used to. So please bear with me. I'm trying very hard. I might have to get rid of that. Let me just write meters per second here, and then I'll put the 32 kilos here. Okay, so what is the question? The question is asking, what is the direction and magnitude of the total momentum of the 2 players? So first of all, we have to work out the momentum, and of course momentum equals mass times velocity. So for the first player, it's going to be 45 times 1.4. And where's my calculator when I need it? I probably have it here. Always have an extra calculator. I've got 3 or 4. Make sure you get enough calculators. You should at least have 2 calculators for the exam, okay? Just in case one of them starts acting up. So let's have a look. 1.4 times 45. So the momentum for that one is going to be 63 kg dot meters per second. And the momentum for that one is going to be P equals M times V. Now, I just want you to be careful with one thing here. They are going opposite directions, so I'm just going to give this a negative sign. I don't have to give this a negative sign. I can give this one a negative sign. It's just that they have to be opposite to each other, right? Because they are going opposite to each other. So this one's going to be 32, and that one's going to be minus 2.1. And that would give me 32 times negative 2.1. and that's going to be negative 67.2. And so the overall momentum, what is the direction and the magnitude of the total momentum? What are the direction and the magnitude? The magnitude is going to be 63 plus that. So the magnitude of the total momentum is going to be negative 4.2 kg dot meters per second. Okay, alternatively, let's say for example I did it the other way around, minus 63 plus 67.2. It will give me 4.2 instead of negative 4.2. So what does that mean? It just means the direction's changed. All right, so this is negative 4.2 and it's headed to this way, right? So because it's negative, I don't actually have to say it's this way. But if I had positive, I would say it's to the left. So the answer is 4.2 kg dot meters per second to the left, or negative 4.2 kilograms dot meters per second. And as long as you know, as long as you show here that this is to the left is negative, and then it'll be fine. Okay, I'm gonna have to get rid of some of this stuff. Can I do that in one swoop? Screen, black screen, nope. Pointer options, erase all on, yeah, perfect. So I'm going to go to question 3 now. Two carts move directly towards one another on an air track. Cart 1 has a mass of 0.35 kilograms. So this is cart 1. The mass is equivalent to 0.35 kg. And the speed is 1.2. So 1.2 meters per second. And we've got cart 2, so this is cart 1. And we've got cart 2, and that one has a mass of 0.61 kg and a velocity of, what speed must cart 2 have? Okay, so we don't know. So that's what we're trying to do. Okay, so in order for the total momentum to be 0, then cart 1, momentum of cart 1 has to equal momentum of cart 2. So P of 1 has to equal the momentum of 2 in order for the total momentum of the system to be 0, because they are opposites to each other. This one's moving this way and that one's moving this way. So I can tell you right now, just by approximating, that the velocity of cart 2 has, because that's double the mass, approximately double the mass, that has to be about half the velocity in the opposite direction. So if I get about negative 0.52, negative 0.55, that's about the right answer. So straight away, I'm just going to write that over here. So negative 0.5 thereabouts, between negative 0.5 and negative 0.6, then I'll know I got the right answer. But that's just something for the side here. So I have to work out the momentum of cart 1, which is 0.35 multiplied by 1.2, which is 0.42 kg dot meters per second. That is what the momentum of cart 1 is. It's just simply mass times velocity. Okay, so momentum equals mass times velocity. I just multiplied the mass by the velocity, and that gave me 0.42. Now I know that that has to be the same in order to cancel out. So now I have the momentum. So 0.42 equals 0.61 times something. Now the only thing I have to remember is, of course, the momentum in this case will have to be opposite to the momentum in that case, because they are opposite to each other. So it's negative 4.42 divided by 0.61, and that's going to be minus 0.69. More or less within the range of what I expected, which is minus 0.5 to minus 0.6. So that is correct. Okay, so in order for the system to have a momentum of 0, the speed of cart 2 has to be negative 0.69. Okay, and that's how you do that one. Let's do question 3. I have to once again get rid of this. Pointer, erase all ing on, yeah. Okay, question 4. Just a second. Okay, so question 4, here we go. A 26 kilogram dog is running northwards at, so here we go, is running north. There's the dog. The mass is equal to 26 kg. The speed is, or the velocity is 2.7 meters per second. And we've got a 5.3 kilogram cat running eastwards at 3 meters per second. Oh, it's so hard to write on this new tablet. The mass of the cat is 5.3 kilos. Okay, what are they trying to find? The magnitude and the direction of the total momentum for the system, right? So basically in this case, I have to find the momentums for each. So once again, it's P equals mv. So for the first one, for the dog, it's going to be 2.7 times 26, 2.7 times 26, which is 70.2 kg dot meters per second. That's momentum of dog. And then momentum of cat is going to be P cat, which is going to be 3 times 5.3, which is 15.9. But we're not done. And we can't just simply add them because they're not on the same plane. So don't make the mistake of just simply adding them, because one of them is pointed this way and the other one's pointed this way. So what do we do? What we do is we actually make a triangle. So the triangle is going to be such that this is 70.2. Don't round. Assalamu alaikum wa rahmatullahi wa barakatuh. I'm recording this again because I've realized after recording the video that the battery on my microphone has run out. It's a wireless microphone, so when the battery runs out, I have to just basically, I don't know that it runs out. It doesn't tell me. So it stopped recording the voice. That's all that happened. So I'm recording this again. Okay, let's go through it quickly. Basically, when we calculate the impulse, with impulse, we only have 2 or 3 formulas that we're worried about. Impulse equals final momentum minus initial momentum. Remember, this is not an explanation video. If you don't understand something here, please go back and watch the original video lesson. And of course, so that means that it's going to equal mass times final velocity minus mass times initial velocity, which can also be written like this, Vf minus Vi. Okay, anyway, question 1 says force and time data. What are we trying to work out? Rank the impulses in order of increasing magnitude. So what I'm going to do is I'm going to draw another row here with columns. Okay, and hopefully that will all be very clear. So change in momentum also equals, there's another formula that we know, which is change in momentum equals force times change in time. So that's another important formula that we're going to be using as well. In this case, that's what we're using. 1 times 1 equals 1. 2 times 0.3 equals 0.6. 5 times 0.1 equals 0.5. And 10 times 0.07 equals 0.7. So obviously the answer to that one is going to be C, B, D, and finally A. Let's go to question 2. Question 2 says 0.14 kilogram baseball is dropped from rest. It has a momentum of 0.78 kilograms meters per second just before it lands on the ground. For what amount of time was the ball in the air? Okay, so the ball, here it is. It's a baseball and it's dropping down. It has a weight force. It has a weight force, and weight equals m times g. So the weight force is going to be equal to 0.14 multiplied by 9.81 meters per second squared. So the weight force is going to be approximately 1.38. So 0.14 multiplied by 9.91, 1.37. 1.37 newtons. So now we have the weight force, which is the force, and we also have the momentum, or the change in momentum, because it says it's dropped from rest. So the initial momentum is 0. The final momentum is the change in momentum. It's the same, 0.78. And so the final answer is going to be change in momentum equals force times change in t. So 0.78 equals 1.37 multiplied by time, whatever the time is. So 0.78 divided by 1.37, and that equals, so t equals 0.56 seconds. Hopefully that wasn't too tricky. Okay, let's clear the page and go to question 3 and question 4. Question 3. During a ballistic test, we have a bullet that's going to be fired across into a gel, and the bullet has a mass of 5.5 grams. It's pretty small, and it's traveling at a speed of 3 to 5 meters per second, which is also quite slow, by the way, for a bullet. And we are trying to work out what is the time needed. We've also got a force. They've given us a lot. 550 newtons. What are we trying to work out? The time it took to stop the bullet once it goes into the gel. Khalas. Okay, it's easy. First I have to work out the change in momentum, the impulse, which is going to equal it's going to equal mass times velocity, or change in velocity, which change in velocity in this case is 325, because we don't have, the last velocity is 0, but the mass has to be changed from grams to kilograms. So 5.5 divided by 1,000. So that's the first thing, is the mass is going to be 5.5 grams over 1,000, because there are 1,000 grams in a kilo, multiplied by 325, and that will give me the momentum. So the momentum is going to be equal to 1.78. 75 kg dot meters per second. That is the momentum. And then I have the momentum, I have the force. What do I do now? Come on, remember the formula. The formula is change in momentum equals force times time. I have the momentum, which is 1.7875, and I have the force, which is 550 multiplied by t. I can find t, so it's 1.78 divided by 550. The time is equal to, therefore time is equal to 3.25 times 10 to the power of negative 3 if you like scientific notation, or if you don't like scientific notation, 0.003 seconds. Okay, thereabouts. That's the correct answer if you want to check that. Okay, I'm going to clear that now because we really have to keep moving. You can always pause the video, go back. Okay, let's move on. Erase everything. Question 4 says, question 4, when spiking a volleyball, a player changes the velocity of the ball from 4.2 to -2. Okay, so I'm just going to go back, a very, very quick, brief explanation. Change in momentum equals P final minus P initial. And remember that equals M times V final. Oops, no, I don't want that. Minus M times V initial, which equals M, because mass is the same, Vf minus Vi, if you know your mathematics. And so we know that that is the formula for change in momentum, just like, or impulse, just like force times change in time. They are both the same. Okay, so what do we have? We have change in momentum. Okay, and we have the velocity. So we have negative 9.3 equivalent to mass multiplied by the final velocity, which is negative 24 minus 4.2. Okay, so therefore mass equals negative 9.3 divided by negative 24 minus 4.2, and that gives you a mass of 0.33 kg, which is equivalently right for a volleyball. Volleyballs are quite light. If you look at football, for example, a football is between 400 and 500 grams. A volleyball is usually lighter than that because you hit it with your hand. Okay, and there you go. That's all. I'll see you in the next one. Okay, Assalamu alaikum once again. We are doing the revision pack questions for unit 7.3. So get your pen and paper ready. Let's go. Right, so conservation of momentum. What does that word even mean? It means that momentum before equals momentum after. Don't you forget it. So the system momentum, the momentum of the system before equals the momentum of the system after. That's all that means. Okay, after what? After collision, after change of direction, after change of velocity. That's what that means. Okay, so after being acted upon. Two ice skaters, question 1 says, two ice skaters stand at rest in the center of an ice rink. So we've seen this question so many times. We've got two people standing in the middle of an ice rink and they push each other apart. Okay, they push each other apart and one of them goes that way, one of them goes that way. Okay, that's what's happening here. We've got 45 kilogram person going, so this person here is 45 kg. We don't know what this person is, so that's what we're trying to find out. The if the speed of the skater is this, what is the skater's mass? So 0.62 meters per second. This one is 0.89 meters per second. And they want to find out what this mass is. Now, before I even start doing the problem, I know that this mass is going to be less than this mass. The reason I know that is because the speed is higher. So obviously, if it's going at a higher speed, assuming that the force acting on it will be the same, then that means the mass is going to be lower. Something has to give. Remember, force equals mass times acceleration. That's what we are concerned with here. And we are concerned with Newton's laws as well. So for every action, there is an equal and opposite reaction. So in this question here, we are talking about a lot of physics, different concepts in physics. We're talking about Newton's third law of motion. We're talking about momentum conservation. We're talking about action and reaction forces. So what do we have? We have force equals mass times acceleration, which is Newton's laws. We also have momentum, which is P equals mv. So the momentum for this person is going to be equal to the momentum of this person. So P equals mass times velocity, which is equal to 45 multiplied by 0.62. In case you didn't know, by the way, I like talking in different accents, and that will just come out sometimes. I don't mean to do it, it just happens. So my apologies if you hear me talking in different accents as I'm doing these videos. It's not something I mean to do. It's just something that happens. 45 multiplied by 0.62 equals 27.9 kg dot meters per second. So that is, let me just get rid of all of this. And sorry about the sound in the background. That's just my daughter. That's 27.9 kilograms dot meters per second. That is going to be the momentum of this person. So that's going to be equal. Both momentums are going to be the same. Okay, both momentums are going to be the same. So now that I have the momentum, I can go back to this person here and go, hey, P equals mass times velocity. And now I know what P is. So I need to find out what M is because I already know what velocity is. They told me. So that divided by 0.89, and so the answer is going to be M for the person is going to be 31.3 kilograms. That is, that is how much this person is. 31.3 kilograms. Okay, I'm going to get rid of all of this mess now. Let's go to question 2. Two rollerbladers face each other. Once again, they're standing at rest in a flat parking lot. Tracy has a mass of 32. We'll give Tracy a skirt so we know she's a girl. Mass of 32 kilograms. And Jonas has a mass of, and Jonas, her brother, he is wearing Ijdasha. He has a mass of 45. Okay, and they push against each other. Jonas acquires a speed of 0.55 meters per second, and they want to know what is Tracy's speed. Once again, let's work with what we have. So P equals mv, which equals 45 multiplied by 0.55. And that equals 45 times 0.55, which equals 24.75 kg dot meters per second. And now that we have that, we bring it all the way over here, Shamsuddin, and we go 24.75. Remember, sorry, P equals mv. Always start with the formula. So we've got 24.75 equals 32 times v. So what does v equal? V is going to equal 24.75 divided by 32, which is equal to v equals 0.77 meters per second that way. That's all for that one. That's the answer. Okay, hopefully you got that one right as well. I'm gonna pause the video for a second while I look at a message that I received on Teams. Okay, and let me just clear all of that. And let's go to question 3. An 85 kilogram lumberjack stands at one end of a 380 kilogram floating log. Okay, both the log and the lumberjack are at rest initially. The lumberjack then trots, that means walks a little quickly on the quick side towards the shore with a speed of 2.7 relative to the shore. What is the speed of the log relative to the shore? So easy peasy lemon squeezy. So that's him. His mass is 85 kilos. This is just going to act in the opposite way. Oh, this has a mass of 380 kilos. Yeah, I was just wondering if that was the mass. So the same exact situation, we got to work out the momentum of the lumberjack, which equals mass times velocity, which equals 85 multiplied by 2.7, and that equals 229.5 kg dot meters per second. So now we have the p value, and then we can go to the log and calculate that the momentum of the log, which is equal to that of the lumberjacks, is going to equal mass times velocity. So that is going to equal 229.5 380 multiplied by the velocity divided by 380. So the velocity, therefore the velocity equals 0.6 meters per second. Okay, that's the velocity of the log. That's the first part of the question, I think. Okay, that's the first part of the question. That's part A. That's part A. Part B says, if the mass of the log were greater, would its speed relative to the shore be greater, less than, or the same as before? Of course, if the mass increases, then the speed would be less. It would be less than. The answer to that one is less than. That's the answer. And it says explain. Well, because look, momentum equals mass times velocity. So if we increase the mass, the velocity decreases. That's all. And let me just write that properly. Check your answer to B by calculating the speed relative to the shore for a 450 kilogram log. So if we replace this by 450, what will be the speed? It will be not 0.6, it will be 0.51 meters per second. So therefore, yes, it will decrease. Thank you. See you in the next one. Okay, Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome back. And this is the last of the videos for the revision pack, unit 7.4. Once I finish with those, inshallah, I'll be posting another video that will include some conceptual questions and some workout questions for the exam, and then I will compile it all together in one mega compilation revision video. Okay, so let's get on with it. Question 1, we're talking about collisions. Question 1 says, and of course, as always, if you are finding these difficult, if you want more explanation, go back to the original video that explains it. So the original video is an hour long, and it explains things. This is not an explanation video. This is one where we just solve problems. Okay, thank you very much. Let's get on with it. So a 0.1 kilogram cart moves with a speed of, here's a cart. and it moves with the speed of, the mass of it is 0.1 kilograms, so like a toy cart, and the speed is 0.66. Oh, I'm not going to write it up there because you don't get to see up there. So velocity equals 0.66 meters per second. Okay. On a frictionless air track, so we ignore friction, collides with a stationary cart of mass, so this one has a mass of 0.2 kg. Maybe I should draw it slightly bigger because it is heavier. 0.2 kg. If the two carts stick together after the collision, what is the speed of the two carts? So we're assuming this happened. So this here stuck to the three-wheeled cart. And this is what happened. So they both stuck together and now they are both moving together at a certain velocity. We know their mass, but we don't know what their velocity is. Their mass is 0.3. Now somebody's asking me, how do you know that? 0.2 plus 0.1. You just add it together. So now it's 0.3. And what is going to be the speed afterwards? Well, in order to calculate the speed afterwards, I need to know the momentum before for both. I need to know the momentum for this and this. This one's not moving. This one has a velocity of 0. So therefore, the momentum for this is 0, right? So the only thing is the momentum for this. 0.1 times 0.66. It's going to be 0.066. Okay? So that is the momentum before for everything, for both carts. The momentum for this is 0.066. The momentum for this is 0. So both momentum combined before equals 0.066. Momentum after, guess what? Momentum before equals momentum after. So it is also 0.066. Can I work out the velocity now? Of course. Velocity equals, come on, P over M. Because the formula is P equals mv. And so velocity is equal to P over M. So 0.066 divided by 0.3. And that equals 0.22 meters per second. Makes sense. So this was moving quite fast. And then it hit this and it got stuck to it. And now it's moving slow. That is the answer to question 1. I'm going to get rid of it now. Question 2. Question 2. A 25,000 kilogram train car moving at 2.5 meters per second. So here is a train car. Mass equals 25,000 kg. And the velocity is 2.5 meters per second. And it just happens to be colliding with, what does it collide with? And connects to a train car of equal mass moving in the same direction at 1 meters per second. So same mass. I'm just going to write it again just to make it easy for you guys to visualize. And for me too. I actually, like to visualize things. What is the speed of the connected cars? Okay. So the momentum of this before and the momentum of this before is equal to, of course, that we have to add all the momentums before. So this is going to be 25,000 because it's 25,000 times 1. And remember, it's m times v. And this is the same, m times v. So it's 25 times 2.5, which is 62,500. 62,500. So now we have to add both of them together, and that will be 87.5. And then what do we do? And then so that is the total momentum before, P initial, and we know that the P final is the same, 87.5 kg dot meters per second. So what are we trying to find out? We're trying to find the speed of both carts after they stick together. We know the mass of both cats is going to be 50,000 because it's 25 plus 25. So can we work out the velocity? Of course, mister. So easy. 87,500 divided by 50,000. And now we know that the speed is going to be 1.75 meters per second. Easy. Hopefully that wasn't too hard. Right, I'm getting rid of that now. If you feel like I'm going too fast, please pause the video. If you don't understand it, go and watch the original video, please. Question 3. Two 72-kilogram hockey players are skating at 5.45 meters per second, collide and stick together. So I'm assuming they're both going in opposite directions, obviously. So mass equals 72, and this boy here has a mass of 72 as well. Velocity of this one equals 5.45, and the velocity of this one equals negative 5.45, or the magnitude is 5.45 meters per second, obviously. Really good practice to always write the units. I don't usually just leave numbers without units. Right, and then what do? If the angle between the initial directions is 90, oops, see, this is why it's really important to read the question, huh? So yes, they are the same mass, but one of them is going... I'm just going to draw the whole thing again. My apologies about that. Hopefully that's a lesson in itself, okay? Make sure you read the question carefully. So I'm just going to draw a bird's eye view. We've got... Oh, this is going to be horrible. Oh God, using this tablet. Bismillah. Go back. That's north. Okay, that'll do. That's north. We've got one going that way, and we've got another person heading him who is heading this way. And this guy is 72 kg, and this guy is 72 kg. And they're both traveling at the same speed, 5.45 meters per second. And this one is also 5.45 meters per second. Now remember, momentum is a vector, so we can actually work out the momentum. Momentum is going to be mass times velocity. So 5.45 multiplied by 72. So that's 392.4. 392.4. And no, I didn't want my face to move. Thank you. You can stay right over here. 392.4. And this one is also the same, 392.4. So what do we do with that? Well, we've got a triangle. Why is it so hard drawing a straight line? Here we go. Perfect. We've got a triangle. This one is 392, and this one is 392. And we are trying to work out the hypotenuse, obviously. So what is this one? No, keep. Excuse me just a second. Here we go. So we are trying to work out the hypotenuse, and of course we know that a squared plus b squared equals c squared. This is c, this is a, this is b. It's a 45 degrees angle. So let's have a look. 392. We've got that, so it's squared. Sorry. A 392 squared plus 392 squared, and the square root of both, so it's about 554. Approximately 554. That's the momentum, kg dot meters per second. We're not done.
We've just worked out the momentum. Now we have to work backwards. Momentum equals mass times velocity. So it's going to be 554 is equal to the total mass, which is 72 times 2, which is 144. Okay. And then we have the velocity. So in order to find the velocity, the speed after is going to be 554 divided by 144. So it's about approximately 3.8 meters per second. That's the answer. Hopefully you got something similar to that. It's not asking you for the angle, but if you were to work out the angle, it's at 45 degrees. The reason for that is because they both, it's an equilateral, no, it's a right angle isosceles triangle. Okay, thank you very much. Stay tuned for the next video.
Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome back, students. And as I have told you before, we are going to conclude our videos, our revision videos, with this mock exam practice. Please make sure you have a calculator ready and a pen and paper. The best way to do this is to actually be doing the questions with me as I go along. So what you do is you give it a go, you answer the questions, and then you check your answers after I do it, okay? So don't just wait for me to do it, okay? Pause the video, attempt it yourself, look at the evidence, look at what you have, look at the knowns, the unknowns, and then you answer the question and you check your answer with my answer, okay? Best of luck. So the way it's going to work is I've collected a group of questions that I think are quite similar to what you might be facing in the exam or what you could face in the exam. You will have some conceptual questions in the exam. The way it's going to work is you're going to have some terms, so there will be some terminology. I just want to make this very clear. You will have to be familiar with definitions, okay? And I've put a few of, well, most of the definitions you'll find in the vocabulary at the beginning of the chapters. So I'll show you where to find those. You'll also have multiple choice questions. You're going to have some short answers, and you might have a question or two where you might have to write a bit of explanation as well. Okay, let's give it a go. I hope you're ready. Okay, so here we go. You will need to get familiar with certain terms, as I've said. So things like what you see over here, those terms. You know what? I'm going to use blue pen today because I'm going to pretend that I'm a student as I'm answering these questions. Okay. So this is the sort of thing you need to be familiar with. Make sure that you go through those. You make sure you understand what this terminology means. Okay, all of these should be familiar to you by now. And of course, the different types of collisions. Now, this is not a conclusive list. That's to say that you should be familiar with most terminology that we used throughout the term. This is not all of it, but this is certainly the majority of it, if not all of it. Okay, so let's go on. Okay, so we're going to begin with some multiple choice questions. In this diagram, a girl sits on a sled and slides down a hill of snow. Which arrow represents the force of friction opposing the motion of the sled down the hill? Okay, so here's the diagram. It's not the clearest diagram, but you can see A is facing upwards, D is downwards, C is up, and B is down. So A is the letter that represents opposing to friction, so that is the answer to that one. Okay. What measurement is used to measure force? Hopefully by now everybody should know that mass is measured in kilograms, force is measured in newtons, energy and work are measured in joules, power is measured in watts, acceleration is measured in meters per second squared, time is measured in seconds. So yeah, so please be familiar with those. Units are important. In the exam, you will lose marks if you don't use the right units. Next, what is the overall force acting on the box? The box has a mass of 50 kilograms. What is the acceleration? So let's have a look. What is the overall force? So what is the net force acting on the box? Over here in the y-axis, we can see they are more or less equal, 25 down, 25 up. So we don't worry about the y-axis. Here we've got 50 and here we've got 100. So overall, we're going to have 50 newtons acting to the right. So that is going to be the overall force, 50 newtons that way to the right. And then the next question is a follow-up question, and it says the box has a mass of 50 kilograms. What is the acceleration? The acceleration is going to be, well, let's see, force equals mass times acceleration. So if it's 50 kilograms and the force is 50, then the acceleration is obviously A is equal to 1 meters per second squared. Okay? Let's move on. Right. Force equals mass times acceleration. Which object would have the greatest force out of all of these? So obviously what we need to do is multiply what we have, the mass. We have the mass over here and we have the acceleration. Ooh. So all of these accelerations are missing the squared. So what do we need to do here? We need to multiply the mass by the acceleration. So that's going to be 50. That's going to be 100. And of course it's newtons, yeah? And that's going to be 80 newtons. And that's going to be 60 newtons. So the one that's going to have the greatest force is the second one. What is the net force acting on the driver? The driver is moving forward. So that could be thrust force from the engine, or push force if it's a toy car. And then we've got air resistance opposing the motion of the driver. So whether it's air resistance, ground resistance, rolling resistance, sliding resistance, static resistance, doesn't matter. It always opposes the direction of the motion. Okay? Anyway, it's going to be, the overall net force is going to be 3 because it's 10 minus 7, so it's going to be 3. And it's going to be forwards. The reason why it's forwards because it's 10 forwards, 7 to the back. So obviously the car is going to continue moving forwards. So 3 to the right is correct. What will cause an object to move? Applied forces. Well, yes, applied forces, but applied forces aren't necessarily unbalanced. So applied forces can be balanced, in which an object will stay put. So let's say, for example, a box that is sitting on the table, that will experience weight force as well as normal force. These are applied forces, okay? However, they're balanced, so it doesn't matter. Another example is a ball where two siblings, a brother and a sister, are pushing against the ball with equal force, yeah? They are pushing with equal force on the ball. Now, since this person is pushing that way and this person is pushing that way, these are applied forces, but the ball is balanced. So, do applied forces cause an object to move? Not necessarily. Do balanced forces cause an object to move? Once again, no. Unbalanced forces cause an object to move. A 230 kilogram motorbike accelerates at 7 meters per second. What is the force acting on it? Okay. So what do we have here? Remember, force equals mass times acceleration. What do we have? We've got the mass, we've got the acceleration. So it's really quite easy. 230 multiplied by 7, which equals, don't expect me to work that out. What is it? 17? Oh, it's actually multiple choice. It's 1610, obviously. Times 7, so 1610. Okay. Let's move on. If a cyclist throws a ball backwards while riding on a frictionless road, what will be the resulting action for the cyclist? Okay, not just the cyclist. If anyone pushes an object backwards, what will happen to them? They'll move forward. ignoring friction, of course, they will move forward. The same thing happens in outer space. It's much more obvious in outer space because there is no ground friction. If you throw anything in any direction, you will move in the opposite direction. If you're in a swimming pool and it's very calm and you're just floating on the surface, especially if you're floating on a floater, if you have a floater, which is like a mattress that's inflated, and you hold something heavy, like a pumpkin or maybe a child, and you throw them, you will see this physics in action very clearly. Just be very careful when you're doing it. Please make sure that everybody's safe. Okay, an object is placed on a horizontal surface. Which of the following is equal in magnitude to the normal force exerted on the object? So the object is placed on a horizontal surface. Let's just say the object is a book and it's placed on a horizontal surface. Which of the following is equal in magnitude? So we've got the weight acting down and we've got the normal force acting up. So equal in magnitude to the normal force, it's going to be the weight of the object. A 150 kilogram boat experiences a force of 450 newtons. What is the acceleration of the boat? Once again, our friend is force equals mass times acceleration, and so it's going to be 150 multiplied by A is equal to 450. Therefore, what we can do is use the formula triangle, because I know some of you are so much more comfortable using the formula triangle. So, oops, what did I do? Oh, keep. Bear with me, please. Here we go, and we're back. So therefore, the acceleration is going to be force over mass, which equals 450 multiplied by 150, which equals 3 meters per second squared. That is the full answer. You don't have to show workout for multiple choice questions. Just in case somebody's asking me right now, you do not need to show workout for multiple choice questions, but it's good practice. In fact, the way I answer multiple choice questions, as you might have noticed, I don't even look at the answers. I work it out, I find the answer, and then I see which one is the correct answer. And the reason for that is sometimes they're quite misleading, especially when it comes to concept questions. So, much better practice to actually figure out the answer on your own, if you can, without using the choices. Now, sometimes you can't. Sometimes you have to read the choices. When it tells you things like which of the following choices is correct, then you have to read the choices. However, if the question has everything you need, figure out the answer, then look at the choices. Okay. So the answer to that one is obviously 3 meters per second squared. Next, which of the following will experience the greatest force? So this is the kind of question where you have to read the choices. But even then, I can always say, if it's going to experience the greatest force, obviously it's going to be the one with the most mass or the most velocity or the most mass and velocity. Mass and acceleration. So because we're talking about force, not momentum. So let's have a look. So here's mass, here's mass, here's mass, and here's mass, and here's acceleration, and here's acceleration, and here's acceleration, and this is not even acceleration. So this one here will not experience any force because it is moving constant speed. So that's not even part of it. This one will have a force of 50. This one will have a force of 6 newtons. This one will have a force of 50 as well. So both B and D. You will not have any questions with two choices in the exam. It'll always be one choice, but this is practice and I want you to use your head. So I will throw in some things like that. Next, which statement about friction is true? Well, I know the first one's true. Friction always opposes the motion. Let's see if any of the others are true. Type of material affects friction significantly. Yes, that's true as well. Both of these are true. Friction is always greater than applied force. No, not necessarily. If it is, then the object is not going to move in case of static friction. If it's not, then the object will move. Weight of the object has the sole effect on friction. Once again, no. The weight of the object can obviously increase friction because it lowers the gap between the surfaces, but it's not the sole effect. It's not the only thing. So the first two are correct. A 2 kilogram block is placed on a horizontal surface with a coefficient of 0.3. So that is the coefficient. We're not told if that is the static coefficient or the dynamic coefficient or kinetic coefficient. But anyway, the coefficient is 0.3, 2 kilogram block. What is the friction force acting on the block? Okay, so friction force is going to equal mu multiplied by, that's mu, but I'm going to draw it better, mu multiplied by normal force. Now normal force is equivalent to, this guy here is equal to weight force, which is mg, right? So I don't have the normal force, but I have the mass, m, which is 2 kg, multiplied by g, which is 9.81, and that will give me w. So w is approximately 19.6, yeah. .62. So I have everything I need now. 19.62 multiplied by 0.3, and that will give me the force. So the force is going to be 5.9. Oh, 5.9 is none of those. Okay, so I think whoever was writing this made a mistake because it's actually 6 newtons, not 0.6 newtons. So if we just pretend that that says 6.0 newtons, then that's correct. Moving on. Which material combinations would result in the highest coefficient of friction? Okay, so this takes a little bit of logic. Rubber on ice, anything on ice is going to have low coefficient of friction because ice is just too slippery. Metal on glass, metal on metal, wood on dry concrete. Yep. Next, which material combination would result in the lowest coefficient of friction? Glass on ice. Oh god, that just sounds so slippery. Yeah, I think that's the one. Let's keep going. What is the main factor that affects the coefficient of friction between two surfaces? Well, we already know that it's the size of the gap affected by the weight of the object and the smoothness of the surfaces. Temperature of the environment. So that actually does affect it, by the way, but we won't mention that. The color of the surfaces, hopefully not. So not this, not this. I think they mean these two. The weight and the smoothness of the surfaces. What is the main factor? I would have thought the smoothness of the surfaces as well, because obviously friction is due to the ridges, the micro ridges in the surfaces that we don't see. So the smoothness of the surfaces would result in, if they are smooth, then it would result in a lower coefficient of friction. Oh well, you know what? That's why we're doing these questions. Some of them are wrong, obviously, but the idea is what matters. And don't worry, in the exam we will not have these questions. We will have questions that are similar, but the idea of this video is to get you to think, okay? Which type of friction is experienced by an object when it starts to slide on a surface? So hopefully by now you should know that it's dynamic friction or also known as kinetic friction or sliding friction. So that is the same as sliding friction or dynamic friction. Dynamic just means moving. Okay, let's keep going. What is the relationship between coefficient of friction and frictional force? So hopefully you know that frictional force is equivalent to coefficient of friction multiplied by normal force. So what is the relationship? They are directly proportional. If this increases, this increases. Okay, if I double this, then I double this. They are directly proportional. Inversely proportional means if one decreases, the other one increases. Okay, so if it's like inversely proportional, less exercise means you're going to gain more weight. Less exercise, more weight. That is inversely proportional. More burgers, more weight. That is directly proportional. Okay? What happens to the momentum of an object when its velocity triples? What happens to the momentum of the object? Well, let's have a look. P equals mass times velocity. Let's pick a mass, any mass. I don't like picking one because one can be quite deceiving. Let's make it 5. So we're going to go with an object that has a mass of 5 kg. So momentum, let's say it's a 5 kg object and the velocity is 2 meters per second. So then the momentum is going to be 10 kilogram dot meters per second. Now if I change the velocity to triple it, I'm going to make it 6 meters per second. So what's going to happen now to the momentum? It's going to be 5 times 6, which is going to be 30. So I triple the velocity, I triple the momentum. A force is applied to an object for a long time. How can the change in momentum be calculated? Okay, once again, change in momentum, which is impulse. Immediately you should write this. Anytime you see change in momentum, you should always know it's impulse is equal to force multiplied by change in time. Okay, so it's basically asking you to say the formula. How can the change in momentum be calculated? It's going to be force times time. So it's dividing the force by the time. No, it's multiplying the force by the time. I already know that's the right answer. And yeah, also subtracting the initial from the final. That is also true. So yeah, but that one's also true. Okay, so obviously, as I said, once again, you will not get a situation where you have to pick 2 answers for multiple choice. It'll always be one. But for the purpose of revision, I want you to look at which ones are correct. Change in momentum, impulse, literally means it says change in momentum. So it's initial minus final, or final minus initial, or as well as force times time. We have 2 formulas for momentum. There is that, and there is also this. Change in momentum equals mass times change in velocity. We also have change in momentum equals P final minus P initial, which is the same as that, because remember it's M times Vf minus M times Vi, which translates to M times Vf minus Vi, or M times change in V. So, it's just rearranging the formula. Which of the following best defines conservation of momentum? Okay, so once again, you need to be familiar with what conservation of momentum is in order to answer this. So the gist of it is that momentum before equals momentum after, or the total momentum of the system remains unchanged. So let's see which one of those is correct. The total momentum remains constant in a closed system. That is true. Momentum is always increasing. No. Momentum is always decreasing. No. Momentum depends on external forces. No. Really, it is affected by it, but momentum depends on mass times velocity. And in a closed system, what they mean by a closed system is that nothing is affecting it on the outside, from the outside. So out of those, that is the most correct. Next, if the mass of an object is doubled, what happens to the momentum if the velocity remains constant? Okay, so this is a similar scenario to the one we had before where it says tripling the velocity, what happens to the momentum? But this time it's slightly different. So let's take a mass of 5 kilograms and a velocity of 2 meters per second. This time we are looking at momentum is equal to 10 because it's going to be 5 multiplied by 2. Now they don't want us to change the velocity, they want us to change the mass. If we double the mass to 10, what's going to happen to the momentum? The momentum is going to double to 20. So it doubles. If the mass of an object doubles, what happens to the momentum? If its velocity remains constant, it doubles. And this is expected. Think of a cat that's moving at a certain speed, and let's say we replace the cat with an elephant. The elephant is moving now. If the elephant is moving and the cat is moving, same speed, which one has bigger momentum? The elephant has bigger momentum. Okay. Which scenario best describes an elastic collision? An elastic collision is one where things bounce off each other. So a baseball hitting a window and breaking it? Not really. A car colliding with another car and sticking together, that is inelastic collision. Two pool balls colliding and bouncing off each other. So pool is that game where you have numbers on balls and it moves. They hit each other and bounce off each other. Okay? So two pool balls bouncing off each other, of course. Okay, so that is the best example of objects colliding in an elastic way. If the force in a collision remains the same, but the time of impact is doubled, what happens to the impulse? Impulse is equal to force multiplied by time. Okay, so if the force remains the same, let's say for example the force is 10 newtons, but the time of impact is doubled. So now instead of 1 second, it is 2 seconds. So if it's 1 second, then it's the change in momentum or the impulse is going to equal 10. But if it's 2 seconds, then the change in momentum is going to be equal to 20. So you can see that it doubles. That is incorrect. The answer is not that. The answer is it doubles. We just did it mathematically. So the force in a collision remains the same. That's the force. But the time of impact is doubled. What happens to the impulse? The impulse is doubled. Okay. Now, if they had said the impulse in a collision remains the same, but the time is doubled, then what happens to the force? Then I will say the force is halved. Okay. So if the impulse, let's change the question. If the impulse in a collision remains the same, but the time of impact is doubled, what happens to the force? Okay, then in that case, it's a different problem. Let's work it out. Okay, then it will be something like this. Change in momentum, which is impulse, is equal to force multiplied by time. And so if the impulse remains the same, let's say it's 10, and the force is 10 multiplied by 1 second. Now let's say I decide, actually I'm going to try and change the time of impact from 1 second, I'm going to make it 5 seconds. So obviously what that's going to do to the force is now the force is a lot lower, and so it is going to be still 10 newtons s, but now the force is a lot lower, right? So in this case, the answer is A for the original question, but for this next question that I came up with, it's going to be less. What is the relationship between force applied to an object and the resulting acceleration according to Newton's second law? Force is equal to mass multiplied by acceleration. And so what is the relationship between a force applied to an object and the resulting acceleration? Well, that's it. They are directly proportional, force and acceleration. So if you increase the acceleration, you increase the force. If you increase the force, you increase the acceleration, and vice versa. Okay. So it is directly proportional. Excuse me while I close the door behind me. Okay. And back to this. Okay, next question. What is the momentum of a 500-gram object moving at velocity of 4 meters per second? So once again, we need to recognize that that is the mass and that there is the velocity, but we have the mass, and the mass is in grams. We don't like grams. Mass is supposed to be in kilograms. So the first thing we need to do is realize that 500 grams is equivalent to 500 over 1000, which equals 0.5 kg. Okay, once I have that, and I know that the velocity is 4, then it's going to be 2. It's going to be, the answer is 2. Next, a car with a mass of 1000 kilogram experiences a force of 5000 newtons. What is its acceleration? Okay, so we've got the mass over here, we've got the force over here. When you're answering these questions in the exam, it's always good practice to answer it in the following, with the following four in mind: formula, workout, answer, units. Okay, and that's what we'll be looking for as well when we're marking. Formula, workout, answer, units. So where's the formula? The formula is force equals mass multiplied by acceleration. The workout is going to look like this: 5000 is equal to 1000 multiplied by the acceleration. The answer is going to be something like this: acceleration is equal to 5000 over 1000. You don't have to be so elaborate, by the way. You can skip this step and just go straight to 5 meters per second squared. And of course, that's the unit, and that's the answer. If an object has a momentum of 20 kilograms meters per second, it should have a dot here, and its mass is 4 kilograms, what is its velocity? So we have the momentum, which is 20, and we have the mass, which is 4, and so we are looking for the velocity. Well, P mv, and so velocity is going to equal momentum over mass, which equals 20 divided by 4, which equals 5 what? Meters per second. An object initially at rest experiences an acceleration of 2 meters per second squared. for 5 seconds. What is the final velocity? Well, the final velocity is going to be, let's have a look. So it's 2 meters per second squared for 5 seconds. So times 5, and that's going to, because it was initially at rest, remember? So that's the change, that's acceleration. Acceleration is equal to change in velocity over time. Hopefully you remember that from term 1. Change in velocity over time. And so we have the velocity, change in velocity. What are we after? We're after the final velocity. So we have the acceleration. Let me just put that in a way that everybody can understand it, hopefully. So we have the acceleration, which is 2 meters per second squared, and we have the time, which is 5 seconds, and we're looking for change in velocity. So it's going to be acceleration times time. Acceleration times time equals change in velocity. So it's going to be 5 times 2, which is 10. Okay, this is the next part of the video. I'm going to take a quick break, and I'll be back in, well, for you, I'll be back in a microsecond. Okay, and we're back. Told you, you won't even know I'm gone. Right, so here's the kind of problem you could have in the exam, where it's asking you for, of course, the exam questions will not look like this. They will have an explanation, so everything will be quite clear. But as far as questions go, what do we want? What do we have to solve here? We have to solve for the final velocity of the van after being hit. Okay. Now, let's have a look. So what we need to do in all cases, it's momentum before equals momentum after. So let's have a look. So the momentum before in this case equals, the only object that's moving is the car. So it's going to be 990. So the momentum of the car is going to be 990 multiplied by 10, which is going to be 9,900. Okay. Well, the momentum of the van is 0 because the velocity of the van is 0. It's not moving, see, red light. Now afterwards we have the car is moving at, the mass of the car hasn't changed, it's still 990, 990. So now it's moving at nearly 2,000, 1,980. That's the new momentum of the car. But what is the momentum of this van here? Well, the momentum of the van here is going to be 9,900, which is the total momentum before, minus 1,980, which is the momentum of the car after. The total momentum before was 9,900. The total momentum after will be 9,900. Same. So since the momentum of the car is 1,980 now, that means the momentum of the van is going to be what's left, which is 9,900 minus 1,980. So that's going to be 7,920. That's the momentum. We're not done yet. We need to find out the velocity. So in order to find the velocity, we divide it by the mass, which is 4,200, because remember we are using the formula here. Momentum equals mass times velocity. So that divided by 4,200, and so therefore the velocity of the van is equal to 1.9 meters per second. Let's move on. Okay, so to give a child a ride, 2 teenagers pull on a 3.7 kilogram sled with ropes as indicated in the figure below. Both teenagers pull with a force of 55 newtons, as can be seen over here, 55 newtons, at an angle of 35 relative to forward direction, which is the direction of the motion. In addition, the snow exerts a retarding force, which means it is resistance force, this is it, of 57 newtons. We can see it over here. Okay, find the acceleration of the sled and the child. Very good. Now that is here, that is a huge hint over here, the sled and the child. So that's just there to remind you, hey, don't forget, it's not just the mass of the child, it's the mass of the child and the sled. So that's nice of them to do that. So what do we have? We have the mass, which is a combination of the child and the sled, which is 19 plus 3.7, which is going to be 22.7 kilograms. That's the total mass. What else do we have? We also have the force. Well, but we don't have the force in this direction, which is what we want. We want this force here. That's what we want. We want the acceleration forward. We don't have that. What we have is this force here, 55. We have this force here, which is also 55. And we have the force backwards, which is 57. So we have to do a bit of work. In order to find this force, I have to find the adjacent. Because remember, this is 55 and that's the hypotenuse. I also have the angle, which is 35 degrees. And I need to find the adjacent, not the opposite. I don't care about the opposite. So the adjacent is going to be, remember, SOHCAHTOA. SOHCAHTOA. So the adjacent is going to be cosine 35. Okay, because we are using cosine. Why? Because cos theta is equal to adjacent over hypotenuse. Okay, that is an H, in case you're wondering. And so it's going to be cosine 35 multiplied by 55. So it's going to be 45. A is equal to 45 newtons. Are we done? No. That's just one A. How many A's have we got? We've got two triangles. That's one triangle. We also have another triangle, almost exactly the same, except this time it's the opposite, like that. Now, we don't actually need to do the calculation because it's exactly the same numbers. So 35 and so on. So that A is also going to be 45. So simply speaking, A is going to be 45 multiplied by 2, which is 19 newtons. Okay, that's great. We have the acceleration. Is that it? No. We have to remember there is also a resistance force in the back. So there is a net force we have to work out. So if A is 90, the boys are pulling with a force of 90 forward. There's also 57 in the back, newtons back. So it's going to be an overall force of 33 newtons forward. So the overall force is 33 newtons forward because of the snow. Now we have the force. So we have the mass, and now we have the force, which was 90 minus 57, which equals 33 newtons. So now we have the force and the mass. Of course, force equals mass times acceleration. That's what they want. They want the acceleration. So acceleration is going to be force divided by mass. So divided by 22.7, then the acceleration is going to be 1.4 meters per second squared. Because we are working with two significant figures all throughout the question, so I'm just going to leave it as 1.4. Okay, hopefully that wasn't too hard. It just took a little bit of thinking. You know, I had to think about which force we're using. We want the force that is moving forward, A, as shown in the picture, as shown in the diagram, and you just had to remember the sled, the mass of the sled and the person, as well as the opposing force back. I like this question, but it did require a little bit of thinking. Okay, here we have two carts of sort. One of them is moving at 4 meters per second, the other one's moving at 4 meters per second as well. The difference is they are in opposite directions. One of them has a mass of 3 kilograms, the other one has a mass of 1 kilogram. And the obvious answer is, once they stick together, what is their velocity going to be? Well, same as every other question, it's about conservation of momentum. Let's work out the momentum of the first cart and the second cart, add it together, then we have the momentum before, and we have the momentum after. which is equal to the momentum before. That's the steps of solving this. So we know the mass is equal to, for this here, we know the mass is 3 and the velocity is 4, and we know that momentum equals mass times velocity, so it's going to equal 12. This one here, on the other hand, has a mass of 1 and the velocity is minus 4, so it's going to be P equals 1 times negative 4. Why negative 4? Because it's opposite to the other one. Does it matter which one's negative, which one's positive? Absolutely not. So anyway, this is negative 4. And now the overall momentum of the system before is going to be P1 plus P2, which is going to be 8 meters per second. 8 kilograms dot meters per second. As I said, another way of doing it is to take the whole. Oh, no, we'll not do it that way. So basically, you have to calculate the individual momentums before, add them together, and then afterwards we have a total mass of what? What's the total mass of the cart? And hopefully, by the way, I hope you're doing it the right way. You're working this out and you're checking your answers with me. So the total mass afterwards is going to be 4 kilos, and we are trying to find the velocity. We have the momentum, which is 8. So obviously the velocity is going to be 2 meters per second that way, which makes sense. Okay, let's move on. Oh, this is the kind of fun question that you really need to know how to do. Wink, wink. Okay, what do we have here? We have 2 cars colliding with each other and going at an angle. Okay, so let's work out the momentum here first, which is going to be mass times velocity. And I think they labeled it as T for truck, velocity for truck, mass of truck, and mass of car, velocity of car. So it's going to be mass times velocity, and it's going to be 3,000 multiplied by 20, which equals 60,000. Now we have another vector to work out, which is this one here, and that's going to be the same. P of car is equal to mass times velocity, which equals 2,000 multiplied by 20, which equals 40,000. Well, now we have 2 sides and we need to put them together, so I'm going to take this and I'm going to take this and I'm going to make this beautiful shape here called a triangle. Okay, and in my triangle I'm going to label these. This is going to be 60,000 and this is going to be 40,000, and I am trying to work out the hypotenuse. Now hopefully you remember a squared plus b squared equals c squared. So if I'm trying to work out c, it's going to be the square root of 60,000 plus 40,000. So that's going to give me 72,000. Are we done? No, they're looking for the final velocity. That's what they want. So how do I work it out? Well, the final velocity is going to be the momentum of both the truck and the car is equal to 72,000. The mass of both the truck and the car is equal to 5,000. So the final velocity of both the truck and the car is going to equal momentum over mass, because it's momentum equals mass times velocity. So they are going to move at 14.4 meters per second. That's the answer. If they are asking for the direction, what do I have to do? If they're asking for the direction, I have to look at this and divide it by this, which is the opposite over the adjacent, and then shift tan. So it's going to be 4 divided by 6, shift tan, and that's going to tell me the angle, which is 33 degrees above the positive x-axis. Okay, hopefully that wasn't too hard. Okay, here we have another question. A tennis player hits a 0.15 kilogram tennis ball with a racket, okay, giving it a speed of 30 meters per second. The ball rebounds in the opposite direction. Oh, okay, I see what happens. So here is the racket. The ball was coming this way at 30 meters per second, and then it rebounded with 20 meters per second, and the ball has a mass of 0.15. And the time is 0.02. Okay, so obviously whenever you see time and it's such a short time, we're usually talking about impulse. Calculate the change in momentum. Change in momentum immediately means impulse of the tennis ball. So they are nice enough to give us a formula down here. So change in momentum is equal to mass multiplied by change in velocity, or Vf minus Vi. So it's going to be 0.15 multiplied by 30 minus, is it minus 20? No, it's 30 minus 20, because it changes direction. Okay, the final velocity is not 20. No, it's negative 20. So it's Vf minus Vi, so it's 30 minus 20, which means 50. So it's 0.15 multiplied by 50. So that is the trick there with that question. So that is 7.5 kilograms dot meters per second. That is the change in momentum. And then it says determine the force. So that's part A. And then part B says determine the force exerted by the tennis racket on the ball. Well, change in momentum equals force times change in time. Do I have the change in momentum? 7.5. Do I have the force? No. But I have the time, which is 0.02. So the force is going to be 7.5 divided by 0.02. Hopefully you know how to do the maths by now. I can't write all the steps. And the force is going to equal 375 newtons. That is the force. Okay, let's move on. Hooke's law. If a spring has a spring constant of 2 newtons per meter, so the spring constant is K. Remember, force equals K times X. This is K, and is stretched by 5 centimeters. This is X. What is the force of the spring? Now the only thing you have to remember is that X is actually measured in meters. This stretch is actually measured in meters, so not centimeters. So we have to change centimeters to meters. Remember, in 1 meter, you have 100 centimeters. Okay, the word centi or centi means 1 over 100. That's where the word cent comes from. If you are familiar with cents, like 100 cents, from a dollar has 100 cents. Cent means 1 over 100. Centi means 1 over 100, or centi. So 5 centimeters means 5 over 100, which equals 0.05 meters. So we've got K, we've got X. Force is equal to Kx. Remember, always write the formula first, then the workout, which is 2 multiplied by 0.05, and the force is going to be 0.1 newtons. Okay? If a spring has a spring constant of 0.5 newtons per meter and is stretched by 0.5 meters, what is the force on the spring? So this time it's more of the same, exactly more of the same. Kx which equals 0.5 multiplied by 0.5. We don't have to change anything this time, which equals 0.25 newtons. Next, what is the value of W? So here we have a spring that has been stretched. So here's the spring in its normal state. Here's the spring in its relaxed state. Here is the spring with 20 newtons on it, so it's slightly stretched. And here's the spring with more weight on it. It's the same spring, it's just been stretched through different uses of different weights. Now, over here we're using 20 newtons, and we know what the stretch is. Over here we don't know what the stretch is. So what do I need to do? I need to know the value of W. I need to know the weight. So the weight, first of all, I need to realize that the weight is a force. So weight equals force. Okay, because we're talking about spring constant, and force equals kx. I'm just going to write that somewhere better. I'm going to write here force equals kx. So what do we need to do? We need to work out the force. We need to know what the force is. We don't know that. Do we know the stretch? We know what the stretch is, I think. We don't know what k is. What can we do? Let's look. What is the stretch? First of all, the stretch is 35? No, the stretch is not 35. The stretch is the difference between the relaxed state and now this elongated state. So the stretch is not 35, that's the total length. We're looking for the stretch only. The stretch is 35 minus 15. So let's find what the stretch is. X equals 35 centimeters minus 15 centimeters. Important that we do that first. So that's going to be 20 centimeters, or 0.2 meters. Now we found the stretch. Now we know what x is. X equals 0.2 meters. Good, we'll keep that there. Next, we need to know what k is. We still don't know what k is. How do we work out k? Right. Well, I can't use the last picture to work out k, but I can use the middle picture. Wait a minute, but we're not working with the middle picture. Well, actually, it doesn't matter because k is the same. K is a constant. It's a spring constant. Constant means it's non-changing. So the spring has a spring constant. It is a number that is special to that spring. Soft springs have a certain spring constant, which means a certain stretch. Strong springs have a different spring constant, which gives them a stronger or a less lenient stretch. So if we work out the spring constant, it'll be the same across the board. It's just for the spring. So how do I work out the spring constant? Well, force equals kx is the same as this. Force equals kx. Do I have the force for the middle one? Yes, the force for the middle one is 20 newtons. And the stretch for the middle one is 25 minus 15, which is 0.1 meters, because it's 10 centimeters. 25 minus 15 is 10 centimeters, or 0.1 meters. So I can work out k. So k is 200. So therefore k is 200 newtons per meter. Guess what? That number is true for this, for this, for this. K is the same across the board. So now I have k. I have k and I have the stretch. Can I work out the force? Of course I can work out the force. So the force is going to be 200 multiplied by 0.2, which equals 40 newtons. So that's what that was. 40 newtons. But actually, there's like a little cheat you can do without even working it out. You can work it out without working it out. So how? Well, the stretch is proportional to the weight. So if you look here, the stretch is 10 centimeters and the weight is 20 newtons. So 10 centimeters for 20 newtons. Here we have 20 centimeters for 40 newtons. It'll be double the weight, double the stretch. That's it. Okay? So even if we don't need to work it out, if I tell you the stretch is 40 centimeters, then you know that the weight is going to be 80 newtons because it's relevant to this. Okay, so that's another way of doing it. Moving on. Brittany stands at rest on a skateboard. The combined mass of Brittany and skateboard is 61. So we have mass equals 61 kg. This is Brittany and the skateboard she's standing on. And the combined mass is 61. Okay, then what do we have? What else do we have? Dave tosses a 3.7 kilogram pumpkin to Brittany. Big pumpkin, and the mass of the pumpkin is 3.7 kilogram. And when she catches it, she and the skateboard roll backwards with a speed of 0.16. So now we have to add the mass of the pumpkin, because it says when she catches it, they both roll back. So the total mass is going to be not 61, it's going to be 64.7 kg, and the velocity is equal to 0.16 meters per second. So the momentum is going to be mass times velocity, 64.7 multiplied by 0.16. So the momentum is equivalent to 10.35 kilograms dot meters per second. That is the momentum, the total momentum after, which is equal to the total momentum before. So that is the total momentum after, which is equivalent to the total momentum before. Remember, initial momentum equals final momentum. So what was moving before? The only thing that was moving before was the pumpkin. They want to know the speed of the pumpkin. All we have to do is take the momentum, which is 10.35, divided by the mass of the pumpkin, as it is the only object moving before, and that will give us, divided by 3.7, and that will give us the speed at which it was moving, which is 2.8 meters per second. Okay? A locomotive engine with an unknown mass is pulling a 1,340 kilogram train car away from the station. The locomotive's acceleration is 1.8, and the force applied on both the locomotive and the train is 5,500. I think there is something missing here. I think they want to know the mass of with an unknown mass. Okay, they want to know the locomotive engine's mass because it says unknown mass. So this is 1,340. This is unknown. This is what we're trying to work out. We know that the acceleration force equals mass times acceleration. We know, and the total force applied to both is 5,500. While the mass we don't know, but the acceleration is 1.8, so we can work out the mass for both is going to be 5,500 divided by 1.8. So the mass for both is equal to 3056 kg. But that's the mass for both. That's step one. Step two is to subtract the mass of the train. So it's going to be 3056.5555, whatever it is, minus 1,340, which equals to 1,340, which equals to 1,716 kg. Okay? Next, in a drag race, a motorcycle pulls a rider with a mass of 80. Motorcycle pulls the rider with a mass of 80 kilograms. The motorcycle accelerates at a constant rate in a straight line. The acceleration causes the velocity of the rider to increase from 10 to 30 in 5 seconds. Calculate the acceleration. Oh, come on. Acceleration equals change in velocity over time, which equals 30 minus 10 over 5 seconds, which equals 4 meters per second squared. Okay, 20 divided by 5, which is 4 meters per second squared. Okay, a car has a momentum of that, and that just means per second. It's the same as writing that. What will the cars, so I'm just going to change all of those here because some of you might get confused by that. That's just another way of writing it. What will the car's new momentum be if its mass is doubled by adding more passengers and greater load and it travels at the same velocity? Okay, if the mass is doubled and it travels at the same velocity, then the momentum will be doubled. It'll be 40,000. If you're not sure, go back to the multiple choices and you'll see some sort of explanation there. What will the velocity be if the momentum is 60,000 kilograms dot meters per second and the mass of the car is 2,000? So it's going to be 60,000, 60 divided by 2,000, which is 30. 60,000 divided by 2,000, which is 30. So that's just going to be 30 meters per second. Number 3 says a truck has a mass of 6,000 and travels at 80 kilometers per hour. So the mass is equal to 6,000 and the velocity is equal to 80 kilometers per hour, which is equivalent to 80,000 meters in 3,600 seconds. Or see, after you've been doing these for a while, you just do these things without even thinking. Like before even reading the question, I just know that I have to do that. How does the momentum change if the truck is loaded with 1,200 kilograms and then travels at 60 kilometers per hour? Okay, so now we just have to add. So what happens is they added 1,200 kilograms to it. Okay, so okay, hang on. So that's P initial. And P initial is going to be 6,000 multiplied by 22.2. So P initial is going to be mass times velocity, which equals 133,200, okay, kg dot meters per second. P final, what did they do? They added 1,200 kilograms to the truck, so now it's 7,200, and the velocity is now 60 kilometers per hour, which is equal to 60,000 divided by 3,600. So 16 points. Oh, please. Oh, not the time. Okay. Oops. What was, oh, I knew there was a delay of sorts. Okay, let's see. Are we still on? We're still on. Alhamdulillah. So 16, oh, stop it. We're nearly there. 16.6. That's 16.6, okay? Meters per second. No, I don't like this color. 16.6 meters per second. So the momentum is going to equal multiplied by 7,200, 120,000. Now that's not the answer though. It's asking for the difference. Just remember, it says what does the momentum change? How does the momentum change? So the momentum change is going to be that minus that. So momentum change, which is impulse, is going to be 13,200. That's the answer. Next, why is it less painful for a high jumper to land on a foam rubber carpet than on the ground? Because remember, this is about impulse, change in momentum, which equals force times time. So the change in momentum is going to be the same. The high jumper, okay, they have a mass. Let's say, for example, their mass is 50 kilos. And the velocity, whatever they land with, let's say, for example, they're landing with a velocity of 7 meters per second. So that's going to be their momentum is going to go from that to 0. So their momentum is 350. The change of momentum is 350, which because that's the initial, and then it's going to be 0. So 350. So we know that change in momentum, this part here is 350. Now we can't change that, but what we can change is the amount of time. So what happens if they land in 1 second, exactly 1 second in contact with the ground? Then the force they experience will be 350 newtons. That force is not bad. It's about a 35 kilogram kid is what they're saying. So there's a bit of a force there. Now what happens if we change the time to 2 seconds? Then suddenly the force is half. It's going to be 175 newtons. And so they experience a lower force. And that's why when we are using foam rubber carpet, what we're doing is we are increasing the time, and because we're increasing the time, we are decreasing the force. Okay, so the impulse is the same, the momentum is the same, the change in momentum is the same. However, because we increase the time, we decrease the force experienced by the person. So that's why it's less painful. Okay, so the moment to take from this is this. If you are jumping off a table, if you are jumping from a fence, if you have to jump for any reason, try to make the transition time longer. Okay, don't lock your knees, don't lock your legs. Try and move with the jump. Okay, move down with the jump and try and make the transition longer. Okay, you will experience less force that way. Next, a spaceship has a mass of 1,000 kilograms. Mass of 1,000 kilograms. Oops, where are we? Mass of 1,000 kilograms. And rocket engine discharges for 5 seconds and increases the rocket's velocity from 25 to 30 meters per second. Calculate the force exerted by the engine to cause this change. Okay, so force equals mass times acceleration, but we don't have the acceleration. Acceleration equals change in velocity over time. Acceleration equals 30 minus 25 over 5, which equals 1 meters per second squared. So now we do have the acceleration, we do have the mass, 1,000, and so the force is equal to 1,000 times 1, which is 1,000 newtons. Boys and girls, I would like to say it's been a pleasure teaching you this year. I wish you all the very best on the exam. I feel like you are ready, inshallah. I hope you continue your physics journey after this exam. I know for some of you, this probably spells the end of physics, maybe even for life. But I hope you do. I hope you continue learning about physics. Physics for me is so much more than a subject at school. Physics for me helped me understand the world, okay? Help me understand creation, okay? Anyway, all the best for the exam. If you have any questions, feel free to send me a message on Teams. No promises I'll be able to answer you. I'll try my best, only because I am a little bit busy and I do have a family. So certainly on the weekends it might be a little bit harder. So if you try and send me a message throughout the week or in the evenings, I'll try my very best to answer you. All the very best. Best of luck.